we're on the same mission as yesterday and the day before, and that is taking everything that we've done and with graphing and do it all without a graph. And so we first looked at slope. We used to count squares, rise and run. Now we have a more algebraic formula-based way of finding the same thing. And we're going to do that with graphing today, that if you're given a point and a slope, how can you find the equation of the line? So a good example of what we're going to be looking at is right here. I gave you a point and a slope. Here's what you guys did on the last test. You were to go to the point and say that's 2, 1. And then you had to use the slope to come up with some other points. So you had to know that this is 1 up 3 right one. And we had to know that, well, that's going the wrong direction. I want to have a y-intercept. So this is the same thing as negative over negative. Because that's positive as well, negative over negative. Down 3, up 1, down 3, left 1. And you can see that we get the y-intercept of y-intercept is negative 5. So the equation here would be y equals 3x minus 5. That's what we did before. So the question is, how can we do all this, get this equation, but without using a graph, without physically seeing a line go through the y-axis and getting a y-intercept? How can we figure it out? Well, it's negative 5 anyway. They already give us a slope, so that part's easy. We already know it's y equals 3x something. That's where we're heading. So let's scoot back one, just review. Anytime it says right slope intercept form, what does that mean? What does that look like? Yeah, it's y equals mx plus b. Where, what does x stand for? Yeah, that's slope. Yeah. And what does b stand for? Y. You might also remember that's where x equals 0. Y-intercept is where x equals 0. So this is the most basic, straightforward question, because they give you everything you really need. Plug it in. As long as you know what slope-intercept form is, and this format, you know that this is the m, this is the b, and just plug it on in. So we have y negative 1/2 x. And then instead of putting plus negative 1, just put minus 1. We simplify anything that needs simplified. Plus and minus, minus. Go ahead and do number 2. Right on your own. Check with someone next to you. Go ahead and check. This requires you to talk. Remember, never be satisfied just saying I got an answer. Make sure it's correct. All right, so what did we get?
Y equals 3x plus 2.
Y equals 3x plus 2, perfect. Okay, so let's go back to where we just left off. How can I get this -5? I mean, we already know it's y equals 3x because they give us the slope, right? But this is not a y-intercept. So, nice thing is, if you write out the y-intercept or slope-intercept form, what do they give us? And the coordinates are, and 2 is what variable? And 1 is the? So yeah, we can still just plug it right in to here. And the only thing that we don't have is b, and that's what we're trying to figure out. Let's do that. Y is equals 1. So 1 equals m is 3. And x is 2. And this is multiplication, so it's 3 times 2. And then the b, that's what we don't know. I'm trying to figure that out. Solve this equation. There we go. Okay. 6 plus what is 1? -5, just as we expected. We're getting the same thing that we got from the graph. So big idea that I've been reiterating is that we should get the same answer regardless of what method. Counting slope, you should get, an answer, but when you use the formula and you subtract, you should get the same exact answer. So, yeah, b is -5, right? They match, and they always will. What's going to happen eventually is like, well, how come we're doing it this way instead of the graph way? Well, eventually the slopes will turn into something like 7/3, and the y-intercept could be like 50.27. And it's not going to be quite as easy just to look and see where the line crosses and get the right answer. It's too difficult when the numbers get don't forget to write the final answer. We already have it over there, but 3x because we have the 3 from right here, but then the b minus 1. So of course it should match whether you get this equation from the graph or if you get it algebraically, you should get the same thing. I'm just subtracting 6 on both sides.
No, the one is above. Like,
that's multiplication.
But like you have 3 times 2. Like how'd you get -6?
I got positive 6. 3 times 2 is 6, and then subtracting 6 on both sides. Okay. Just the variables on the right hand side, so let's go over here. Small doesn't work. Alright, so let's try a few more. Go through it a little bit faster. Get the hang of it. The directions will tell you to put in the slope-intercept form. So as soon as you see it in the direction, just go and write out the slope-intercept form. This is one of those things that it kind of tells me when I'm checking your homework. If you say I didn't get it, and you didn't even write this down, that's kind of a lack of effort. Because I know you know what this is. So start off with this regardless. I'm pretty sure you know that this is x and this is y. Right? And you can do that. Then doing slope, you know that's m. Go ahead and plug it all in. What's 1? 5 equals 7. That's 1. Plus b. 5 equals 7 plus b. So 7 plus what is 5? -2. 7 plus -2, or 7 minus 2 is 5. So, if I was to graph this, I expect this to go through the y-axis right here. I equation is y equals 7x minus 2. Well, it's verified just by looking at the graph. Start at 1 comma 5. 1 comma 5. And the slope would be 7 over 1, which we can't really do. We can't go up 7, right 1. But we can go down 7, left 1. Negative and negative, because negative over negative is positive. So when we go down 7, left 1, sure enough, we get a y-intercept for negative 2. Now you guys won't have this graph on your homework. I just want you guys to see it works both algebraically and graphically. Same exact answer. Alright, you guys try this one completely on your own, and then check someone, see if you got it. Go through 3, 3. So hopefully the fractions don't throw you off. We got 3 equals negative 2/3 times 3. And nice thing is that the x and the denominator of the slope are compatible. We got 3 equals negative 2. Negative 2 plus what is? Solve that. 5. Y equals negative 2/3. And 5. And we do the same thing over here. Start at 3, 3. And if we went up 2, left 3, we'd get positive 5 as well. So it worked out. If you ever have a doubt, you could always kind of sketch this and see if it sounds right. So if you got an answer like negative 5, you can probably see that, well, there's no way this is going through a negative 5 way down here, so something must be wrong. And you can kind of have a slight indication that it's wrong. Yeah. So a good example would be here, that if I'm starting at 1 comma 2, and I have a slope of 5 over 4, I can't go up 5, I can go down 5, I can go left 4, but if I try to graph this, you can see, like, well, you really can't see. What decimal is that? What fraction is that? Now you can't, is that a half? Is that 2/3? This is why we need this algebraic method, because realistically we don't have these nice numbers. Pretty much up to this point you've been given all these nice numbers just so it worked out. And you can see it, on the graph, but that's not realistic. So let's try it and see what fraction. We do know it's going to be between 0 and 1. So if you got a fraction that's like negative 2/3, that's not correct. So let's help us a little. Look for a number between 0 and 1, probably closer to 1 than 0. Okay, so here we go. Y equals y. M x plus b. 2 equals 5/4 times 1, which is just 5/4. Okay. So 5/4 plus what is 2? So how many more fourths do we need to get to 2? And 2 is how many fourths, by the way? 8, yeah. So we're trying to figure out 5 plus what is 8, basically. Yeah, 3/4. So subtract 5/4 on both sides. 8 divided by 4 is 2/4. common denominator. Line with denominator of 4. So 8 times 5. So yeah, it turns out, and that makes sense, that concurs with our prediction that, okay, this is between 0 and 1, but a little bit closer to 1. But impossible to just get this by looking at it. You know, that's 0.75. How would we not know it's 0.74 or 0.70? Really no way to tell unless you have this algebraic method. Y equals 5 fourths. Okay. And then plus 3 fourths. So let's flip over to the homework. I'm going to remind you that we're going to do a couple reviews. Review problems in the beginning and at the end of the homework. In the middle, you'll have stuff that looks just like what we just did. So the first review, the first 4 problems, determine the slope and y-intercept, and write the equation in the graph. So we did this on the last test and on the final. So you have to read this and understand, not just when they don't say the slope is this and the y-intercept is this. Can you read something in real life and figure out, like, well, this is the starting point and this is how fast it's moving. This is what's changing. Okay, so reading this, what is the starting point and what is changing? What is moving? Okay, so we get a new job and receives a $500 bonus. After that, it makes $200 a day. Okay, so what's the starting point? 500. We're starting at $500, and then how do we make more? How much more money do we make? 200 every day. So that's how much we're increasing by. That's how much we're moving by. So how can we write an equation? Y equals 200x. So 200. Remember, this means right here 200x. That means $200 every day. That's what this means right here. Making $200 every day, plus the $500 that they gave us just to start off. Okay. Very similar to all the other stuff we've been doing, like the tow truck. You know, gets $50, and then it's like 25 cents every mile. Okay. Start at 50, and then go. You know, you get a quarter every mile or something like that. So it's always a starting point, and it's always increasing or decreasing. The jacuzzi problem, it was a negative slope because it was losing a gallon of water every minute, or 10 gallons every minute. All right, so you have to read these and understand, here's where we're starting, here's how fast we're moving. Where we're starting, how fast we're moving, and then this one, we want to graph it. Also, write an equation for these as well. It's just the same. Here's what we just went over. Practice that a few times. Let's start off a little bit easier, and then we'll get into fractions and negatives and things like that. And then real fast, we go right back to review. Just graph a few of these. They're already in slope-intercept form. Start at the y-intercept. Make sure you know that the slope of 2 is 2 over 1. That means up to right 1. Okay, up to right 1, and you'll get your right graph. Pay attention to the scale. Like this one counts by 2. So when you're going up to right 1, make sure you actually use, it's not 2 squares, it's going to be 1 square here because each square counts as 2. So mind the scale. Okay, mind the scale. So more review. Last 4, same thing. You just have to do solving for y first. Okay, so for instance, on number 19, you can just add 4x to both sides. Divide everything by 2. we have y equals 4 divided by 2 and 10 divided by 2. And you can go up to right 1 or down to left 1. Either way, it's the same thing. Alright. I will check all the homeworks tomorrow. They'll all be due tomorrow. Remember, with this, we are going to try tearing out the pages of the book. So if you want to now, you can tear out and staple individually each homework and have it all ready to turn in tomorrow and be stamped. You've already had a few days for most of the assignments, so if it's not finished tomorrow, that's it. You got to get things done at least in one day. Okay, remember tomorrow's